Assistance for People with Motor Disabilities ARPH. Robotic assistance for the disabled aims to replace motor functions lost by the person, essentially mobility and manipulation. The robot is a system that can perceive, act, decide, and communicate to interact with the environment, autonomously or in cooperation with humans. We aim to help disabled people benefit from the service provided by the robot for two reasons. The first is to reduce the complexity of the machine by taking advantage of the person's perception and decision-making skills. The second is to maintain natural active rehabilitation by involving the person as much as possible in the task. The scientific problem is part of a field of research known as computer-assisted teleoperation, CAT. We have opted for a semi-autonomous mobile manipulator robot that assists the disabled person in moving and/or manipulating objects. The term assisted is ambiguous and needs to be clarified. From the robot's point of view, the term assisted implies that the robot has autonomy functions that enable it to perform certain tasks only partially and that the user must assist it. From the user's point of view, the term assisted means that the user is provided with control modes and feedback to facilitate remote control of the robot. We have therefore focused on two major scientific themes: autonomous robotics and human-robot interaction. This poster presents two projects developed within the HANDS team involving the ARPH robot. Project 10 Degrees 1, the block diagram in the poster illustrates the link between the user and the assistance robot. This link can be broken down into four main control modes, depending on the person's residual abilities and the robot's autonomy capabilities. Pure teleoperation: the user controls the robot directly, without assistance. Assisted teleoperation: the user controls the robot with assistance. Assisted autonomy: robot performs tasks with user assistance. With pure autonomy, the robot performs the task on its own without assistance. With regard to man-machine interaction, we worked on both robot control modes and user feedback, based on the concepts of appropriation introduced by Piaget and affordance proposed by Gibson. This approach is referred to as ecological. This field of research requires multidisciplinary collaboration, both to take into account human-robot interaction, psychology, neuroscience, and the needs of end users, disabled people, medical staff, caregivers. This work has been carried out in partnership with the Rennes Experimental Psychology Laboratory and the Marseille Neuroscience Laboratory for Research, and the AFM as a user association. With regard to autonomous robotics, we have developed autonomy functions for robot mobility and object manipulation. With regard to mobility, two functions have been developed. Localization, which answers the question "where am I?" has been addressed in three ways. Displacement, which defines the path to follow to reach a destination, and then to follow it while avoiding obstacles. One of the difficulties is that the environment in which the robot evolves is dynamic and imperfectly modeled, if not unknown. Manipulation is covered in Project 2, which is described below. Project 2, Exploiting Degree of Freedom Redundancy in the ARPH Mobile Manipulator Robot. The problem is that gripping an object in space requires 6 degrees of freedom. The ARPH robot has 8, 6 for the manipulator arm and 2 for the mobile part. We can, therefore, exploit the redundancy of degrees of freedom to add constraints. The idea we've adopted is to coordinate the different degrees of freedom of the manipulator's arm during a movement so that the manipulability of the robot's gripper is always optimal. The constraint we added was an original measure of manipulability called directional manipulability. The figure shows the value of this measure in two perpendicular directions for a given configuration of a 3-degree of freedom manipulator arm. Our work also compared the classical global approach used in robotics and, based on our manipulability measure, the directional approach versus a locally resolved multi-agent approach.